Good morning, everyone. Morning. Welcome to Linux Fest 2015. And thanks very much for coming. This is Peeling Back the Layers of Network Security with Security Onion. I am Gary Smith. I am at the Pacific Northwest National Laboratory in Richland, Washington. I am actually in what they call EMSL, Environmental Molecular Sciences Lab. We do lots of things having to do with chemistry, biology, stuff like that, but that's not what we're here to talk about today. We're here to talk about one aspect of security, namely security monitoring. How do you think about security? Mostly you try not to think about it, or you don't really think about what you have to do security. This is how I think about security, to give you a little bit of security context. I try to think about security based on what I call the 5 golden principles of security. And if you go out to the internet, you'll find these in different places. The only thing I will take credit for is ordering them in this particular order because it makes them easy to remember. No is at the top and the bottom. Principles 2 and 4 both start with P, and the central concept is the one in the middle. Know your system. Know what runs on your computers. Know what your network traffic looks like. Know how people are using your computers. Know what systems are talking to what systems, what kind of traffic to expect. We know how our cars generally operate. If we hear a funny noise, we think, uh-oh, the fan belt is loose or something like that. Use that same sort of technique to knowing your systems. Principle of least privilege. Don't give a process, a person, a system, a network object more privilege than it absolutely needs to do its job. This is particularly true of managers. You don't need to give your boss root privilege. This is a pathway to hell. Another way to look at this is don't give individual users on systems root. This is another pathway to hell. Take it from me, I know. Defense in depth. Defense in depth. That says don't just do one thing and say you're secure. The best example of that is, I got a firewall, I'm safe. Wrong. That's not enough. Think of security as being like the cross-section of a tree. You've got rings in there. Use different rings to protect your security so that if you have a breach at one place, there's a backup, and so on and so on. A good example of this is a castle in Fougères, France. This castle has not one moat, but 2 moats, a double moat. So the barbarians come through, and they smash through, and they get past the first moat, and then they go, oh, crap, there's a second moat. Well, let's just go to the castle down the street, because this is too much work, and they'll be easier to get through. Protection is key, but detection is a must. You can patch, you can make sure your systems are all up to date, but if you don't know that something is going wrong, you've lost the ballgame. And that's what this is mostly about today, is that detection part, knowing that something has gone wrong so that you can act on it. And the first one, which is knowing your system. The last one is know your enemy. Know the techniques that the enemy is going to use to break into your system. Learn those techniques. Try them out yourself. See how they can get in. Okay. Anybody here have an IDS at their location? Anybody want to admit? Okay. I'm going to ask a question that our previous president would probably ask at this point. How's that IDS thing working for you? Is it working for you? Is it doing what it's supposed to? Is it giving you lots of false positives? So what is an IDS? Intrusion detection system. They're usually passive in nature. They just sit and listen for traffic. If something comes across that maybe is unusual, they raise an alarm. They do it by any number of techniques. A lot of them are signature-based. So when there's a new problem on the network, you've got to wait for somebody to send out a signature. Another one is some type of anomaly-based system where if it sees unusual traffic, it will send out some kind of alert. Or maybe it does some sort of stateful packet analysis. Oh, this isn't doing the TCP handshake right, so this is probably a problem. Or it may do some combination of all three of these. The main thing that IDSs have in common is that they generate lots of false positives. If you have ever put up an IDS system from scratch, the best advice I can give you is for that first month, somebody says, hey, how's it going? Is it working? And you say, oh, it's working just great, because it's going to give you lots of false positives and probably tell you things about your network that you really didn't know were going on. But let's say that you've got an IDS out there and it's running and it's doing its thing. What if something bad goes wrong? What if data breaches are occurring within that organization? Do data breaches occur? Sure. Target, Home Depot, you name it. It's almost like breach of the week. You open up the paper and you see who's getting breached and whose social security numbers are being compromised and passwords and user accounts and whatnot. Does anybody work at a place where they have BYOD, bring your own device? Okay, lots of places. My personal opinion is that BYOD stands for bring your own disaster. A lot of people are implementing BYOD and they aren't doing the requisite security that goes behind that, so somebody brings in a laptop or an iPad or an Android pad or something like that, and it's got some flaky software on it, and it goes out there and does malicious things. Another possibility is rogue devices. You got a rogue device behind your firewall. What's it going to do? I have an example of that from a place I used to work. I used to work with a bunch of engineers who were doing development for 4G telephony. And this group had a very, very expensive oscilloscope. This thing was something like $50,000. And it had an operating system. It had a Microsoft operating system doing all of the stuff that it needed to do. So that meant it had Internet Explorer. And one of the engineers who was using it went out to a compromised website and downloaded, as a result, a piece of rogue software that then tried to take over the whole network. And he wasn't doing anything wrong. This just happened. But fortunately, our IDS caught it in time, and we turned off the oscilloscope and ended up putting a new version of the operating system on it. But this sort of thing can happen to you, and you don't even realize it, because who knows what kind of operating system, what kind of software is running beneath these very complicated devices you may be putting on your network. So an IDS is just not enough. It's not enough to take care of the problem of what's going bad on your network. So what's the solution for that? The solution, possibly, and for lack of a better term to call it, is network security monitoring. This is much higher level than you get with an IDS. So what does network security require? It requires you to be able to capture and store large amounts of data. For instance, with the cost of storage going down and the cost of systems going down, there's really no reason why you couldn't capture all the packets going across your network and saving that data in some sort of format for later use and analysis. When you're tracking an adversary using network security monitoring, you have a large context of data that you can look at and determine what actually went on. Whereas with an IDS, you may know that something has gone wrong, but you don't know what led up to it and what happened afterwards. You just may know that something is going wrong. A lot of CIOs, CISOs, they believe that NSM is something that you just buy, you put it in place, you turn it on, and then you just walk away from it. That doesn't work. The essential ingredient in network security monitoring is that M part. For instance, let's say you're doing physical security around a plant, and you put up cameras on poles around the plant, and you have these all feeding into monitors, and then you don't have anybody watching the monitors. It doesn't make sense from a physical standpoint. It doesn't make sense from a cyber standpoint either. If you're going to monitor stuff, you need to have somebody looking at it, and that's what the very basic part of this is that M part. So, how do you get network security monitoring? Well, there are lots of products that you can probably buy, and they do a reasonably good job. My personal favorite is something called Security Onion. And it was created by a guy named Doug Burks at Mandiant. Mandiant has since been bought by somebody, so I'm not sure who got bought by. But it is a whole distribution that gives you that network security monitoring. It is a tremendous package. Doug could probably make a small fortune selling this, but he gives it away for free. So, what is Network Security Onion? What does it give you? The main thing that Security Onion gives you, as opposed to so many other pieces of software or distributions that are out there, is that Doug and his coworkers have managed to seamlessly weave stuff together and integrate stuff together to give you three functions that are vital to this network security monitoring package and thought. One is full packet capture. If a packet comes across, grab the whole thing. Don't just grab the IP, the sender and the port and all that. Grab the whole packet. The next is some kind of intrusion detection associated with it. NIDS and HIDS, network intrusion detection, host intrusion detection. And the last one is analysis tools. Once you've got that data and scooped it up, store it away. Then these integrated analysis tools can look at it and give you the flow of what actually happened. So let's talk about each one of these for a little bit. Full packet capture. Full packet capture, sort of like what Jay is doing over there with me right now. It's a video camera for your network. It's capturing what's going on. If we go back to that physical security model where we've got cameras up on poles, the video cameras are taking pictures, they're putting them on displays, they're storing away on videotape somewhere, hopefully. What that full packet capture gives us is it gives us information about what the payloads we came across. Phishing emails, who sent it, where from, to whom, what are the URLs enclosed in that phishing email. Let's say that somebody starts sending out large amounts of data to another site. This may be Fred in accounting stealing accounting records, and he's sending it out to somewhere out on his Gmail account. File exfiltration. Exfiltration is a good spy word that's gotten real popular lately, but if you have, going back to those 3 years of Latin I took in high school, if the opposite of in, as in coming in, is ex, going out. Another thing, if you want to think about it, is if pro is the opposite of con, what is the opposite of progress? think about that the next time you pull the lever on the voting machine. Full packet capture. Full capture is done with a thing called NetsNIF-NG. It is an enormous packet capturing beast that sucks at all these packets in. This is what gathers all the packets so that all the downstream stuff can look at the packets that you've got. For network intrusion detection, it gives you a choice. One of them is the old workhorse of network intrusion detection, Snort. Snort has been around, forever. It seems like it's been around forever. But there's a new kid on the block called Suricata, and it comes, oddly enough, from another DOE lab. The main difference between the two is that Snort is single-threaded, and Suricata is multi-threaded. And you wouldn't believe the flame wars between the Suricata developers and the Snort developers about whether or not you need threading or not. But you have your choices on that. Another component is Bro. The first time I heard somebody mention the Bro network security system, I unfortunately thought of the French last name, Bro, and thought, okay. And then I later learned that it was spelled B-R-O, and I thought of it more, now I think of it in terms of the contraction for brother. But Bro is a wonderful piece of software that does categorization of the network data that is coming in from NetsNIF-NG, and we'll see an example of that. Host security. Security Onion comes with OSSEC for doing host security. Has something critical on your system changed. The nice thing about OSSEC, as opposed to other things, is that there are versions of OSSEC for Linux, there are versions of it for Windows, and there are versions of it for Mac OS as well. So you've got pretty much everything covered right there for doing host security detection. For your analysis tools, and there are a lot of them. One of them that is really amazing is one called Elsa. Elsa comes out of Google. Google gives away the code. You can go out to SourceForge or any number of other places and look at the capabilities of Elsa. Elsa is sort of like it's been called a free version of Splunk, but it allows you to look at the captured data in lots of interesting ways. Elsa is a real drag to build. I've never managed to build it successfully, but somehow or the other, Doug Burks and his crew have managed to do this and integrate, and not just build it, but integrate it with all the other pieces of Security Onion. And that's what makes Security Onion so distinctive and so useful, is this level of integration that he has managed to work into this. SnoreB. SnoreB is buzzword compliant. SnoreB is Web 2.0, Ruby on Rails, Ajax. It's got great features for packet analysis. And the thing about Snorby is that managers love it because it makes pretty graphs. It really makes some very pretty graphs. So your manager, or perhaps more realistically, a junior analyst can run Snorby and pinpoint, oh yes, I see a problem here. And they don't require a lot of teaching. But like I said, managers love it because it does produce pretty graphs. Elsa, that I was just talking about, is not so much on graphs, but boy, is it good for the analyst to use. Another one, Sguil, which is pronounced Sguil. Squeal has been around for about 15 years. I remember when I first heard about it because Squeal stands for Snort GUI for Lamers. Yeah, And that was the original intention, is that it was something that a relatively untrained person could run and look at Snort signatures and Snort data. It is much more than that now. It is of, by, and for the network analyst. And it is real time. SnoreB is not, that I was just talking about, is not real time. But it gets a lot, it takes in a lot of information from a lot of different places. It takes in stuff from Snort or Suricata for your IDS information. It takes in stuff from Bro. There's another piece that is integrated into the Security Onion package called PRADS, Passive Real-Time Asset Detection System. So if a new piece of equipment suddenly pops up on your network, PRADS detects it and that information gets transferred back into Sguil, so that you know if a new piece of hardware has suddenly appeared on your system, like maybe a rogue device of some variety or the other. Squert. Squert is a program that takes that data that Sguil has and gives you a different view of it. For instance, it gives you the ability to have a traffic matrix view of your data, so that you can see that this system over here is talking to this system over here, and by how much. So those are the basic analysis tools. Now, what about installing Security Onion with all of this stuff? With all of this stuff, all of these things, and this is not all that goes into Security Onion. There's a whole lot more stuff underneath that you don't see that contributes to this whole big workflow. You would think that with all of these packages there, that installation and configuration of Security Onion would be a tremendously time-consuming thing. It is not. The intent that Doug Burks had when he created Security Onion is that a Windows system administrator could take the ISO, drop it into a PC, and within 30 minutes and clicking yes, 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 have a completely functioning network security monitoring system. And yes, it really is that easy. All you basically have to know is, what interface do I want to use for a management interface? What interface do I want to have for my capture interface? Is it DHCP? Is it manual? Yes, 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 yes. Boom. That's about it. That's really it. In 30 minutes, literally, a Windows admin can have this going. Isn't that amazing? That is the level of integration that he has done. And speaking from personal experience, working with some of these other packages like Barnyard and Snort and Snorby, I don't know how long it took him to get some of these things integrated, but boy, it is amazing that he has gotten so many things to play together and play together nicely. So, what do you need to have a network security monitoring system based on Security Onion? Well, first of all, you need two NICs. You need one for your management interface, and you need one for packet capture. That's all you need. Memory. This is one of those your mileage may vary sort of things. It depends on what you want to monitor, how much traffic you're getting in, how much you want to monitor, what kinds of traffic you're getting in, and what you consider to be an acceptable amount of data to keep for your organization. Now, one of the things that is really nice about Security Onion, and if you have to deal with syslogs, you probably know this to be true, is that you have to go through and you have to purge some of your syslogs periodically out. Well, Security Onion, if you do a df-h on your system that's running Security Onion, you will see that it is generally always 90% full. And that's because Security Onion is set up to automatically expire stuff off. So you don't have to worry about that. and it will generally always be 90% full. So the more disk you can put with it, the more you can keep. There was a book in the 1980s called The Soul of a New Machine. It was about the development of an entirely new computer from start to finish. And one of the characters in that book had a great line that I think about a lot, actually. It goes like this: nothing helps virtual like real. So the more memory that you can put into your box really helps the performance of all the things that are running on it for Network Security Onion. One of my Network Security Onions that I've got has 32 gigabytes of RAM in it. So that allows me to just balloon everything up, and it can keep a lot of things in memory, and it really improves performance. Storage. The more you can store, the better. And disk space is really, really cheap these days. You can go down to Fry's and buy 3 terabytes of data for almost pocket change. At one point in time at a place I worked, I had 1 terabyte of disk space spread across multiple disks, and it cost me $22,000. But now you can go down to Fry's and you can buy 1 TB and stick it in your pocket for less than $100. Of course, the speed between those two is radically different. But still, you could take a box, cram 3 terabyte drives into it, and keep a large amount of your network security data stored there. Disk space is cheap these days, so don't cheap out on disk space unless you just have to. How do you put Security Onion out there? Security Onion, you can deploy it in 3 different ways. One is standalone, where you've got everything running on one box. If you have a large network, you may want to do it as something different. Another mode that you can set up Security Onion is in a server and sensor mode, where you have a central server that does all of your analysis, and then you deploy small sensors throughout your network. Going back to that idea about physical security, where you have the perimeter and your cameras up on fences, same sort of idea. You put sensors out there for the cameras. You put sensors out there at your various important points within your network. And then that all comes back to the central server. Now, one of the things that separates Security Onion from a lot of other similar things is that the data stays on the point of collection. It doesn't get sent back to the central site. The central site queries a sensor when it needs something, and only then. So you're not clogging up your network with unnecessary traffic going back to your analysis station, and you're not having this important security data potentially being scooped out by some nefarious person that may be on your network. So a combination is having both standalone and the client-server model out there. Just as a suggestion, if you want to try this, if you have those sensors deployed out there, put Security Onion on a VM on your workstation and use that to do your analysis. Your network may not have that kind of capability, depending on the way things are partitioned, but that's a possibility. Okay. So let's see. Let's go ahead and do this. Okay. So, in conclusion, with NSM, we get full packet capture. Everything that comes into the network is being captured, and it is being written off to disk. Snort or Suricata, that's our rule-based intrusion detection system. It's looking at that. Bro is looking at events. We have host intrusion detection via OSSEC if we want to go down that route. But OSSEC is included as part of the distribution on the sensor, so that if something goes wrong on that sensor, maybe somebody compromises your sensor, OSSEC would let you know that that is going on. This is all running out of the box. It was easy to set up. There's lots of things that go into Security Onion that I haven't talked about. If I had just had a list of stuff to talk about and went through and talked about each one, I could probably do that for an hour. But this is the basic highlights. But the key thing is that all of this has been seamlessly woven together into something that is easy to use, it is easy to install, it is easy to configure. It's literally as easy to install as Windows. And I kind of raise my eyebrows at that, because having installed Windows before, it's not necessarily that easy. Most people think Windows is easy to install because they go down to Fry's and they buy a new laptop, and that's their idea of installing Windows. So, references. This is all going to be in the slides that I'll upload later on. And if you want to get in contact with me, there's my email address. And that's all of that. Now, let's see. Is this it? No, that's not it. Now the question is...
If you just said something I didn't understand.
Thank you.
And this video will be on YouTube in a few days.
Okay. Now, let's see. Where did... Okay. Now, I have got Security Onion running in a VM. I have gone through the installation procedure. I've gone through the setup, and there are two types of setups you can choose. If you've never installed it before, you just want something done quickly, you can just take the quick install, and it's literally yes, 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 boom, that's it. You're all set, ready to go. Once you've got it all going, if you log into the console, this is what you get. There's the Security Onion emblem, and then there's any number of tools that you can fire up. We talked a little bit about Squert. Squert is a program that lets you view the data from the packet captures, letting you look at things like a traffic matrix. Sguil is the old workhorse that's been around for about 15 years. It's interesting. It's a Tickle TK application, so you pretty much have to run it from the console. Snorby is the one I talked about. That's all the buzzword compliant pieces. Elsa is from Google. It stands for Enterprise Log and Security Analysis. And then there's the setup wizard there. Let's go ahead and fire up Sguil. And let's see. Oh yes, and one of the things it asks you in the setup is, what do you want your username and password to be? Username and password is the same across all the tools, which is really nice. Oops. Sure did. Yes. Remember when Bill Gates demoed Windows 95? Was it Windows 95 or Windows 98 for the first time? It blue screened on him. Yeah, there is karmic justice in the world. Boy, Well, obviously I don't have enough coffee this morning. Better. Hey, score 1 for typing. Okay. Just a little thing here. This is my attempt to be clever and cute. The system name is Cipollini. Cipollini is a kind of onion. Yeah, I have. That's just kind of I'm kind of silly that way, in that I've been naming the sensors and stuff after various different varieties of onion. It's also a little bit of an in-joke if you happen to be into cycle racing, because Cipollini was the name of one of the great sprinters of a few years ago. So what we'll do is we'll go ahead and say, yes, I want everything, and go. And that's basically what it looks like. It's got, shows you events, it shows you packets, shows you the data within the packets. So it's clearly something designed for the network security analyst. Now, okay. Anybody here watch cooking shows? Yeah, you watch cooking shows, okay. Usually the guy who's doing the cooking show, he's got something like 24 minutes to prepare a 7-course dinner. So what he does is that he goes through all the preparation steps, and then he puts this into the oven, and then he takes the fully completed thing out of the oven and sets it down for you, because otherwise you'd be there for 3 hours watching the stuff just cook, and that's terribly uninteresting on TV. I'm going to do a similar sort of thing here. What I'm going to do is I'm going to shoot some packets across the interface and get something going. So what I'm doing is I'm going to use TCP Replay, which takes captured PCAP data, and I'm going to shoot it at an interface, my second interface, which is my monitoring interface. And let's see, where did I put them? Okay.
What does the switch antenna do?
That gives a slight delay. Otherwise, we will overrun stuff. We'll still see some arrows shooting across here, but
so the traffic is actually seen by ETH1 as if it was real traffic.
yes, yes.
The PCAP is not aware of the fact that it's fake replayed.
No, no.
Interesting. I've been looking for tools to do that.
Yeah, yeah. I've used TCP Replay is a really great tool if you've got captured PCAP data, because what you can do is you can shoot it. If you've got, say, something set up that's a monitoring interface, you can shoot it at that interface, and it appears to be real traffic. It's really great. There was a project that I was doing for a 3-letter agency a couple of years ago, where I was trying to model the type of traffic that they were going to be seeing, and seeing how well this particular instrument worked. And that's what I did. Is I had PCAP data from somewhere, and I would just use TCP Replay and just shoot it at that monitoring interface, and it was just like the real thing.
And Echelon was born.
And what?
And Echelon was born.
Right. No, actually, well, can't talk about that. Anyway, but yes, there are lots of options with TCP Replay to simulate the network traffic. If you've got PCAPs and you want to test how something is going to go, just use TCP Replay. It's great. It's got lots of capabilities. So bingo, and away we go. And let's bring this up real quick. And lo and behold, gee, remember I said that Sguil was real-time? Well, this is showing the real-time stuff going on. This is just as if this were real traffic. Oh, gee, we got some red stuff over there, don't we? Okay. That's kind of interesting. Pardon? The different colors are danger levels. John Cleese, bless his heart, John Cleese, of course, of Monty Python fame, wrote a rather interesting piece about different color levels for security warnings based on country. One of the funnier ones I think had to do with France, talking about the security level being mauve or something like that. It was truly inspired. Let's see. Okay, let's see if we can see anything interesting here. See if I can. Okay, let's move this over just a little bit so that you can actually see. Okay. With the detection, there is an event message that goes with it. ET, that doesn't stand for extraterrestrial. That stands for emerging threats. That's a group of people that write Snort signatures and make them freely available to the internet at large. That's another thing that is really good about Security Onion. You don't have to worry about where emerging threat keeps its latest version of threats. It goes out there and periodically downloads them for you, unrolls them into the proper directory, and restarts Snort for you. You don't have to do that. You don't have to be aware of where it is, where it needs to go, or the operational characteristics of it. Security Onion does that for you. That's another nice thing about it. Let's see if I can find where, what am I looking for? Ah, okay. Yeah, I think this is it here. Yeah, here we've got, PADS has detected that a new asset has popped up on our network here. And it's going out to this particular place. There's another new asset, and it's running mail. Let's see. It's kind of hard to see this without having a full screen. Let's see, where? I'm looking for one where they have run Internet Explorer. I beg your pardon?
They shouldn't be allowed to.
Yeah, I know, but hey, what can I say? Yeah, has anybody tried the new thing, Sparta?
Yeah,
How is it?
it's still got a lot of populated, but it's clean and it's fast.
Okay.
Some really good markup tools too. It's not even really hard.
Let's see. Ah, I think there we are. Okay. Okay. Notice this a little bit right here. Here we've got a source IP, and emerging threats has detected that this thing has downloaded an XE or a DLL. And it also is making a, notice that this is a packaged executable. So we may have some possible badness going on here. Let me flip over here. Okay, so we've got some traffic here that looks a little bit suspect. This is much easier on a bigger screen. Okay. Let's select that. And we see it's red. Oops. Let's see if I can get this to scroll up any better. Okay. Let's not do that. Okay, well, I don't have the screen resolution to do what I want to do. It's coming off. Anyway, but what you can do, shame about this, of course this is a demo, so something's obviously not going to work and I don't have enough resolution on the screen to be able to scroll things up. But this particular thing here, where this place went off to that destination IP and it downloaded a packed executable. What I can do with just a few clicks is I can look at the whole scenario of that machine coming online, using Internet Explorer, going out to that particular address, downloading that packed executable, and then whether or not that executable ran on that system. I can also, with just a few clicks, capture that downloaded piece of malware into a separate file. Now, once I've got that file, I can do any number of types of checksumming on it to get a checksum value, and I can go out to any number of places. There are several within the Department of Energy. There are several on the internet that have checksummed malware so that you can say, okay, this file name is named krt.exe, but it is in fact really a Zeus Trojan. Or, since I've now got it captured away in a file, I can put it into a sandbox and determine what it actually does. This is the really neat part about Security Onion, is that it has made everything work together. I mentioned Snorby. Let's see if I can get Snorby to come up. Hello? Wake up. Snorby was the buzzword compliant one that I said was the favorite of managers and junior analysts. That's also the problem with running with things in a VM, is that memory's got to come from somewhere, mostly from the host. Yeah. Gee, this worked back at the office. Okay, finally we get to the point where Chrome is trying to tell us that, yes, I'm trying to protect you. I'm not going to let you run something that might be potentially malicious because I know what's better for you. So we will go ahead and proceed, going to our local site. Remember what I said about memory? Yes, this is also true for VMs as well.
Can I ask you some questions while we wait?
Please go right ahead.
Is this what you run in your production environment? Do you use this in production?
Oh, yes, absolutely.
Are you doing this with 1 gig NICs or 10 gig NICs?
Both.
What line rate are you able to see? I mean, are you capturing at 10 gig line rate or probably like 2 or 3, or what are you seeing?
This is a setup decision that you can make. Snort is single-threaded, so Doug and company at Security Onion have done some tricks to make Security Onion, to make Snort work even though it's single-threaded, by using something called PF ring to capture multiple instances of data, so it's sort of like a load balancer for Snort. If you're really concerned about when you start getting up into the 10 gig range, you're probably going to have to run Suricata because you need that threading to handle the packets coming in. Snort tends to saturate at about somewhere between 2 and 3 gigabytes per second on a NIC. That's why they have PF ring running so that you have like a pipeline going into multiple Snort instances. But if you're doing 10 GB, I would recommend doing going the route of using Suricata instead. And you can select that in your advanced setup. If you just pick the simple setup, you get Snort. Okay, let's see. Yahoo. Hey, success. Okay. This is what the Snorby dashboard looks like. It gives you categorizations right off the bat. 104 high severity, 10 medium severity, 57 that are low severity. The severity comes out of the emerging threat stuff. And there we have a nice graph showing, oh gee, well we didn't have for the whole day. It tells us what, if we just mouse over it, it tells us what sensor it was, if we had multiple sensors.
So this one is or is not real time?
Pardon? Snorby is not real time. Sguil is real time. Squert is real time. This is not. This is more of a post analysis tool. So click on severities and it shows you what the severities were. We have high, medium, and low, and if we mouse over it, it should give us a value. We can look at it by protocols and see that most of it is TCP. In terms of signatures, wow! Now you see why managers love this kind of thing and why this is good for turning over to a junior analyst, is that we see all of these percentages, malware, NetBIOS, lots of NetBIOS. If I put a system up on the internet and within 5 minutes I don't see somebody probing it on UDP 137, 138, 139, I know I have bad network continuity because because somebody, mostly China, is going to be out there probing it within 5 minutes. But gee, wow, look at all, it makes this nice, wonderful pie chart that shows us what types of badness we had and relative percentages. Let me go back up. Another good one is, what are our sources? Where's all this badness coming from? And it shows us the amount, and if we mouse over it, it gives us the actual number counts. And who are the destinations? Who are the big players? We can instantly see that as a pie chart too. So this is a great tool for managers to look at because it makes nice, pretty pictures that they don't have any trouble interpreting. Managers love pie charts. Managers love pie charts. The reason they love pie charts is because it's food. They understand food. They understand food real well. And but there's more things that the analyst can do with it. And hopefully this will work. And how are we doing for time? We're almost there. Okay. And it looks like it's going to do something. Bingo, the actual events that happen. We can then go back and look at individual ones. Like, for instance, this is the one that I was talking about that was a red one. We can look at the individual pieces of it. And there's the actual, hello, no. Okay, there's the actual HTTP record that got captured that we can go back and look at. And we can do other fun stuff with this also. We can, from Snorby, we can capture the HTTP traffic and look at it. But this is just a small snapshot of Security Onion. Security Onion, the great thing about it is that everything is well interweaved together so that with just a few clicks, you can get at that piece of malware that was downloaded. You can look at the whole session that transpired. You don't have to go out there and look at and figure out, well, where are the PCAPs and how do I section this stuff out and how do I manipulate the PCAPs? It's much, much easier to do so that you can get to your analysis that much quicker. That's all I have. I'm probably out of time for questions. Thank you. Yes, sir. Question?